You know what the biggest problem in the programming community is? It's that nobody understands bash redirects, including myself. I have never seen or met a single person, a single programmer, engineer, whatever, system administrator who properly and completely understood bash redirects. So in this episode, I want to have a look at bash redirects and shed some light. And I think I already have a clue what could be stopping all of us from properly getting them. So after this video, at the end of this video, we should have a way better idea about bash redirects than before, than right now. So we're going to learn quite a bit. And I would suggest let's just jump right in. I have an empty directory here. And we all know that we can echo something using the echo statement in bash. So let's echo hello. And as you can see, it appears on the console, and that's because the echo command by default opens the file descriptor standard output and writes stuff to standard output. Standard output has the file descriptor 1. Remember that, it's important. And now what happens when somebody wants to redirect that output to a file? Let's say into this text file. Then no output is printed to the console, and that is because the output has been redirected and it's now in a text file. Great. Now, what I think is stopping all of us, all of you, all of us, from really understanding what's going on here is that we use this shorthand notation. This is not full syntax, and it hides what's actually happening. So what's the full notation here? We echo something, hello. And by the way, of course, the text file now contains the text hello because it has been redirected. All right, so what's the full syntax here? We are hiding some information right here. We have to specify which file descriptor we want to redirect. And because we want to redirect standard output, we have to specify 1 here. Standard output is a 1. I think we can even look that up in the man pages. As you can see, there's those 3 standard streams: standard in, standard out, standard error, and they are file descriptors in the system, and they should have fixed values here. On program, can you even read that? I don't think so. Now you can read it. On program startup, the integer file descriptors associated with the stream standard in, standard out, and standard error are 0, 1, and 2 respectively. So standard out has file descriptor 1, standard error has file descriptor 2. And those are assigned on program startup. So when the program echo starts, it is assigned the file descriptor 1 by the operating system, or God knows by whom, by someone. Someone tells that program, hey, this is file descriptor 1 and it's standard output. And echo writes to standard output to 1. And here we specify we want to redirect file descriptor 1 into, think of an arrow pointing at something. This is an arrowhead pointing at the target file, into this file. So bash effectively bash effectively watches like a hawk over the file descriptor 1, and anything written to it is redirected into the file. So let's hit enter. And as you can see, not much happened because it's the exact same thing as this thing here. And it has just written something into the file. Now, why is this, in my opinion, the point that most of us misunderstand or overlook? It's because now this syntax easily makes us aware of the fact that we can redirect any file descriptor into the text file. So if we want to create an error messages text file, then we can just specify we want to redirect file descriptor 2 into it. And as you can now see, we have a new file that's called error because it contains the redirected error messages. And if I cat that file, it's empty. It does not have any contents. And hello is printed to the console after invocation because we have just redirected file descriptor 2 into error. It's super simple, right? And now we can just build on that by doing the following. We can redirect file descriptor 2 into error, into the error file, and file descriptor 1 into the text file. And now we have invoked some command that generates standard output and standard error messages. And the standard out messages are redirected to error. The standard error messages are redirected to the standard out messages are redirected to the text file, and the standard error messages are redirected to the error file. So if we just clear the file system and re-invoke that same command, then those files are created in the file system, and error is empty, text contains something. And now comes the magic. You could technically even do something like 3 and redirect it into the file 3. 4, redirect it into the file 4. Now new files are created and those could contain content. They don't. So let's have a look. And 3. So they are both empty, and that's because the echo command does not open those file descriptors. Yeah, but you could code any program that opens file descriptor 77, file descriptor 789, file descriptor 13. And then in this command here, in this chain of redirections, you could specify the file descriptors that you want to redirect to specific files. And I would suggest that we should do something like this. So let's create a new small program and let's call it outputs. And let's create a small program that outputs messages to standard out, to standard error, and maybe one more file descriptor that is not even utilized by the system by default, but we just do it ourselves because it's the program's logic. So what we need to do is probably just include standard IO. Yeah, makes sense, standard IO, so we can act on the IO stuff. Let's create a main method. And what we do is we just generate a couple of messages that are printed somewhere. I think printf by default prints to standard out. We can confirm this in the man page here. And this is, by the way, how practically every Linux application is developed. And we're going to mimic that in this video so that we all understand what happens under the hood when we do redirections. So this is the printf command. This is the printf bash command, not the C command. Wait, what did I want to do? Let's look up. There was fprintf. It's fprintf. That is like a generic printf command that not just prints some format string to somewhere, but it prints that format string to a file descriptor. File, this pointer thing, is a file descriptor. Okay? Or we can even do, and that's quite nice, maybe that's even better for the sake of this video, dprintf takes an integer file descriptor and prints some string to it. Let's look up that one. I haven't ever seen that. It never pop up into my eyes. The function dprintf is the same as fprintf, except that it outputs to a file descriptor, fd, instead of to a standard IO stream. Yeah, so the difference is just that we specify a number instead of creating the file descriptor object ourselves. I would say let's try dprintf and let's output to standard out. This message goes to standard out. And before we continue, let's keep it super simple and let's just try to compile this. And I like to enable all the warnings, gcc, w all, enable the debug flag, w extra, and even enable pedantic. Those flags, they force me to correct my errors before the compiler compiles the source code. And pedantic does not work. I think someone put it in the comments. It's pedantic. This was suggested to me by a user. I didn't know that one, so I'm trying it in this episode. And now we have a compiled file that's called out. Wait, I'm removing it because I prefer to have a specified output file name. So let's just give this a file name, outputs. And now we have a binary that's called outputs, and it outputs something to the console. So let's invoke it, outputs. And as you can see, it printed a message to standard out. So that seems to work. The only thing that I want to fix is the new line at the end of this, such that we have a line break. And we can now also continue with printing something to standard error. Here we are opening file descriptor 2. So let's put a comment here. File descriptor 2 is standard error. And file descriptor 1 is standard out. And let's copy that. And file descriptor 3 is our own custom file descriptor. And this message goes to standard error, and this message goes to the custom file descriptor. Okay. Now let's switch terminals and go into that directory again, and let's invoke the compiler with the flags that I want. And it's probably completely overpowered for this small printing program, but who cares? Outputs and outputs.c. Okay, let's execute. And as you can see, we have a couple of messages. And they are all printed to standard out currently. And that is because by default, everything goes to standard out goes to standard output. Standard error is also by default redirected to standard output. And for the file descriptor 3, I introduced a small error because here there's still the 2 specified. So this is also printed to standard error. Accidentally, we have to specify our own file descriptor. So let's compile and execute in one go. And as you can see, now it prints the standard output message here. The standard error message is by default also printed to the terminal. And the third message, which goes to our custom file descriptor, it just vanishes into thin air. It's going nowhere. Yeah, so let's try to remove all those files that we created previously. And let's play around with the redirections. Yeah, so we are generating 3 messages. And what have we learned in this episode so far? We have learned that we can call the outputs command. It outputs something to the standard output, but not everything, because some things are private. They are custom to our application. The application opens file descriptors, but it doesn't mean that the bash shell is going to redirect all of them to standard out. Okay. Let's focus on the standard out and standard error messages first, the first 2. If we want to just redirect standard output, then we can do the following. We just specify 1, file descriptor 1, which comes from the fact that we opened the file descriptor 1 here in the source code. So whatever is printed to file descriptor 1 goes to the, let's call it log file. Let's call it log. And as you can see, now we have a log file that contains this message goes to standard out, and the other message, standard error, was not redirected. So it appears on the terminal by default. Now we can extend our command to redirect standard out to log and standard error file descriptor 2 to standard error. And now we print nothing to the console. But we now have 2 files, the log file and the standard error file. Okay, and that's just because we specified that we want to have those 2 redirections here. And now we can also tell the bash shell that whatever this executable writes to the file descriptor 3, which bash has no idea what it is. It's just custom to the program. Whatever is written into the file descriptor 3 is redirected into the file custom. And let's cat the custom file. And as you can see, this message goes to the custom file descriptor. So this is really something that most people do not understand, because everybody shortcuts themselves by writing this arrow syntax and hiding from themselves the implementation details or the actual system details that go on under the hood. So if we output just something, let's see what happens if we specify nothing here and we write that into a log file. Then let's cat the log file, and as you can see, it contains just 1 message, although 3 messages have been generated. So 1 message is generated, it's inside the log file. The other one is printed to standard out because it is redirected to the terminal by default. This is the standard error message. And the third message, it just goes nowhere. Okay, now a very, very common question is, how do we merge the file streams that we output to into a single file? Yeah, because for some of you, in some applications, it's just not convenient to have multiple separate files that contain the outputs to the different file streams. And for that, we basically use a very similar command. So let's start with invoking outputs again. It outputs something. And then let's say we want to store the standard out message and the standard error message in one file. Then we have to specify that we want to have standard error redirected, and this is the syntax we are already familiar with. And now comes a new thing. The percentage sign and 1. And this, no, it's not percent. Is it the end? No, it was the end. Sorry guys, forget percentage. It's the ampersand. So this syntax means we want to redirect anything that this executable outputs to file descriptor 2, this thing right here. We want to output anything that this executable outputs to file descriptor 2 to the same thing as file descriptor 1. This is a shorthand for a file descriptor because the normal syntax is file name. This would output standard error to some file name. And if we want to output to another file descriptor, we have to prefix it with the ampersand. So the ampersand is always followed by a number, which is a file descriptor. And this means standard error goes into the same thing as standard output, as file descriptor 1. Let's execute it. And as you know now, this changes nothing because standard error by default goes to the same output as standard out anyways, because by default, the bash console, or no, the terminal displays standard out and standard error messages. So if you say you want to redirect standard error to the same thing as standard out, by default it doesn't change anything because this is the default behavior. And you can now think of any command that you execute in the Linux terminal or in your bash shell. You can think of any command by default as doing exactly this. So any command that you invoke is doing this. You're just not typing it. So the next step would be we want to print both of those into a file. Now that we have explicitly stated that we want to send standard error into the same thing as standard output, we now have to just say where standard output goes. So standard output goes into some file name. Let's call it merged. And if I understand correctly, this should mean standard, the order of execution is important here. We have to say the following, merged. So standard output goes into a file that's called merged. And standard error goes into the same thing where standard output also is redirected. Let's try this. And as you can see, there's nothing printed to the console, but we have a new file merged. And if we print that, it contains both standard output and standard error messages. Now, writing this is also already something that nobody gets up until now. And I've been a software engineer for years. I always had to look up those things online. I always had to Google those things. But if we understand that we just specify a file descriptor, a redirection, and a target, it's quite simple. And the target can either be a file name or it can be a file descriptor. Now, if we reverse the order of execution here, just to show you, this will result in the following. It's outputting the standard error message to standard out because the first command here tells standard error to go into the same as standard out. And standard out at this point is not yet set to redirect to the merged file. Yeah, and that's why why you have to pay attention to the order of execution here. Yeah, so if you want to redirect to the same thing as file descriptor 1, you first have to set up where file descriptor 1 should go in your scenario. Okay, but this is how you set up the redirection of multiple streams into a single file. Let's just output the merged file again. But now we know that we have, and this builds on this basic knowledge, we have a custom program that also includes messages or outputs messages to the file descriptor 3, which is custom. And this should be possible to just be redirected as such. We redirect 1 into merged, we redirect 2 into the same thing as 1, and we redirect 3 into the same thing as 1 as well. We could now also do 3 into the same thing as 2, because 2 is the same thing as 1. So this is a chain of logic here, but let's keep it like this. So 1 goes into file, 2 goes into same as 1, and 3 goes into same as 1. Let's output and let's cat merged. And as you can see, this file now contains all 3 messages. And this is effectively how you redirect stuff anywhere. If you want to, well, now you can do basically anything. Now, if you understood this right now, then you understand all redirection stuff in Bash. That's it. And now what you can do is you can say you want to redirect 1 into merged, and you want to suppress error messages, for example, by redirecting them to dev null, which is a file descriptor that just swallows your load of data. And so 2 is redirected into dev null, so it goes nowhere, and 3 is going into the same as 1, so into merged, and this would merge into one file, the standard output and the custom file descriptor output. Let's check if this worked. And as you can see, we have the standard out message and the custom file descriptor message in this file. So this is really, it's not that hard. You just have, it's just a problem that everybody is using this shorthand notation. This one, to redirect stuff in their day-to-day life. Then they redirect something and it just doesn't end up the way they expect it to. Now, is there anything else? Yes, there's one more shorthand that I want to include in this video. But if you want to take away something from this video, it's all of that stuff that we just talked about. Now, for merging standard output and standard error into one file, there's a shorthand, another shorthand that is a shorthand for this syntax here. No, for this one. So this is the standard complete syntax to redirect standard output into a file and redirect standard error into the same file. But since this is done so often, and since it's just used so often in Bash, there's a shortcut for that, and that is just the ampersand and the redirection operator and specifying a file here. And this by default concatenates, or not concatenates, this by default redirects both standard output and standard error into the same file. So if you want to redirect standard output and standard error into the same file, then you don't have to write this notation. I highly recommend you do this because this trains your brain to think of the redirections correctly. This is the correct way to do it. This is the full syntax. But this down here would be a shorthand. I think even the recommended way is this, but both of those syntaxes, ampersand followed by arrow operator or arrow operator followed by ampersand, they do the same thing, as you can see. It's just a matter of preference. I think this one down here is recommended. Yeah, but if you use only the shorthands, for example, the outputs redirect into file name or outputs redirect ampersand into file name, then you don't really know what's going on under the hood. And I think we learned what's going on under the hood in this video excellently. So let me just prepare a final view of the terminal of the things we just did today. Let's switch those panes. And as you can see, so this is the final result of today's episode. We learned how to redirect anything, any stream, anywhere. We've coded our own very, very simple C executable that prints stuff to various file descriptors, and we played around with redirecting those streams into other file descriptors or into dev null or into file names. So it's actually not that hard. Yeah, you just have to understand it once, and I hope now that you watched this video and you tried to follow it, maybe even you type the same commands on your terminal, now that you try to learn it once, it sticks with you. And I think nobody really explains this on YouTube. I've seen so many tutorials, or well, not so many because I'm not wasting my time, but I've seen some tutorials on YouTube which just tell you the commands, but they don't really explain what's going on under the hood. That's it, guys. That's the complete way to understand bash redirections from ground up. It's not hard. You just have to get it once. Thank you for watching this. Stick around, leave a subscribe, and also a like. Videos that are liked by you, they perform much better than videos that are not. And put any feedback in the comments, any special cases that I maybe did not cover. I don't know. I'm not the magic wizard of bash wizardry. And yeah, see you next time. Bye bye.